In this video tutorial, we shall see addition of two 16-bit unsigned numbers. Let us first see the logic of the program, right? So we all know that the registers of 8051 are 8-bit because 8051 is a 8-bit microcontroller, right? So here we are supposed to add 16-bit numbers, right? So definitely our registers cannot hold this 16-bit. Fine. So let us understand this by an example. Let's say I have a 16-bit data F9 67. This is my first 16-bit number, which I will call it as num1, and I have num2. Let's say this is AA 87, both in hexadecimal, right? So I need to add this now. So if I add this, what will be the result now? So let me take a calculator. So F967 plus AA 87. So what I get is 1 A3 EE, right? So 1 is the carry. So this is the expected result. Now the logic is simple. The logic is first we shall take the lower byte. Okay. If I separate this out, so this is the lower byte of num1 and this is the lower byte of num2. So first I will add 67H plus 87H, right? So if I add 67 plus 87, so what I get is EE, right? And there is no carry, right? So when I perform this at the first addition, that is of the lower byte, I will use the instruction add, right? And I will store this result now. Next, what I will do is I will take the next number F9H AAH, right? But when I add this, I have to consider the previous carry. In this case, the carry is 0. Okay, it may happen that the previous addition might have generated a carry. That's why when you add the higher bytes, we have to use the instruction add with carry, so that if there was any carry from the previous addition, then that carry would be considered here. Now that we don't have any carry here, so carry is 0. So we shall see what is F9 plus AA. It is 1A3, right? So A3 will be stored in the destination, and we got a carry out of 1. So this we have to place the result, right? And this is the expected result, 1A3 EEH. This is what we saw when we added the two 16-bit numbers, right? So before you start writing the program, you should know where you want to store your data, right? So for example, let's say I have memory locations 30H, 31H, and 32H and 33H, right? So I have 4 memory locations now. Now, the way you plan to store the data, based on that you can write your program. Let's say I will place the lower byte, that is 67H, in 30H and F9H in 31H. So this is my num1. I can write lower byte of num1. This is very important, and this makes your programming a lot easier. And next you can write here as higher byte of num1. Then I will store 87H, then AAH, right? So this is what lower byte and higher byte of num2, right? And the other thing you have to plan is where you want to store the result. Now that I have the size of the result, maybe maximum maybe 24 bit, right? You have to store the lower byte of the result, higher byte of the result, and also if there is any carry. So for that I shall plan to store in, let's say, R5, R6 and R7. You can plan to store even in memory as you wish. So in R7 I will store the lower byte of result. So in this case it will be EEH, right? And here I shall store the mid byte or the higher byte of the result. So in this case it will be A3H. Here I will store the carry if generated, right? So this is how I am planning to write my code based on this storage of the data, right? Now we shall see how to write the code. So over G0H. So first I shall add the lower bytes. So I am storing the lower bytes in 30H and 32H. So in case of addition, one of the operand, the destination should always be accumulator. So I will bring one of the operand in accumulator. So this is lower byte of num1. This I will add with add a comma. So where is the lower byte of num2? It is in 32H. So 32H. So this is lower byte of num2. Right? Now after this, I am planning to store the result of in R7. So the result is in A now. So I will say move R7 comma A. So this is lower byte of result. Right? So what I have done is the first logic. So this addition might have created a carry, right? So that I will consider in the next addition. So next I will bring the higher byte, move A comma 31H. So this is lower byte of, sorry, this is higher byte of num2. And now while I add, I will also consider the previous carry. So this will be add with carry, A comma 33H. So this is higher byte of num2. This I will store in R6, move R6 comma A. So this is higher byte of result. So this addition might also have created a carry. So for that what I will do is I will say jump on no carry. If there is no carry, I am not supposed to do anything, just skip it. But if there is a carry, I have to move 1. Move R5 comma hash 1. So this is nothing but carry out, right? And skip will be end of the program, is jump skip, right? And this is the end. That's it, right? As a precaution, what you can do is you can initialize R5 with 0. By default, all the registers are initialized with 0, but if you want, you can, right? So let us debug this. So I need to initialize the memory now. So 0 into 30H. And make sure that you are working in data memory, right? Now what to be stored? We can come here. In 30 it is 67. Then F9 is the higher byte of num1. Then 87 is lower byte of num2. Then AA is the higher byte of num2, right? So let's execute this. So in accumulator I got the lower byte of num1. Now I am performing the addition. So the result is EE. So this I am moving to R7, right? So I got the lower byte of the result. Next I am reading the higher bytes. So F9 is in accumulator. So this F9 I am adding with the higher byte. So I got the result as A3, and you can also see the carry flag. So carry flag is equal to 1. right? So I'll transfer the result to R6. Now here I am checking whether I got a carry or not. So in this I have got a carry, so this condition will fail, right? That's why it will come to the next instruction, and this whatever the carry out it was generated, so that will be sent to R5. So you can see the result 1A3EEH. So that is what we had added. So this is how we do a 16-bit addition in a 8-bit microcontroller. And this can be extended for any number of bytes. You can do 32, 64, 24 as you wish, right? And we can also write a generalized program to perform this addition. Okay, so that's all about the logic and the program for adding a 16-bit number.